Hello, dear guys. I hope all of you are fine. Today, I would like to draw some light on the phenomenon known as peer production. And this peer production is a result of a well-known equation of Albert Einstein: E is equal to mc square. So, the peer production is basically the conversion of electromagnetic radiation into the materialistic particles like electron and positron. So positron is an anti-electron. All of its properties resemble are same as that of electron except its charge. So a photon has zero rest mass. And when a photon is in motion, it has energy. I should say that you cannot have a photon actually at rest. Now the point is that this photon, under certain conditions, under certain circumstances, can translate into material particles. These material particles are electrons and positrons. So if you see here, you must have a photon, but what is required here is that the energy of this photon should be nearly equal to 1.02 mega electron volts. So any energy that is less than that of 1.02 mega electron volt would not materialize into material particles. And the next important condition is that this photon, probably the energy that we have here, 1.02 mega electron volt, if we compare it with electromagnetic spectrum, it coincides with the energy of the gamma ray photons. So a gamma ray photon, when it moves in vicinity of a strong Coulomb field, when it moves in vicinity of a nucleus, a strong Coulomb field, then this energy of gamma ray photon can be materialized into two particles. One is electron and another is anti-electron. Now this anti-electron is also called as positron. So the point is that the domain of energy that we are talking here, you won't be able to experience a photoelectric effect or Compton effect in this energy range. So Compton effect and photoelectric effect, they become irrelevant when you talk about the energy of the photon equal to 1.02 mega electron volts. So you can see here is an equation. So this equation will represent the peer production. This equation is h nu. This is the energy of the gamma ray photon. This must be equal to E negative plus m naught c square plus E positive plus m naught c square, where this E negative is the kinetic energy of the electron and this E positive is the kinetic energy of the electron. And all of you are well aware about m naught c square. This is the rest mass energy of electron. So this equation gives you the translation of a photon into moving electron and positron. Now, what is important for peer production to take place? The important thing is that the energy of this photon should be greater than that of twice m naught c square. If we calculate this m naught c square, its value comes out to be 0.51 mega electron volts. So if you multiply this number with 2, you will exactly get the energy of the photon that's required in this case. So when you have a photon whose energy is 1.02 mega electron volt and it is moving, it is allowed to move in vicinity of strong Coulomb field, then this photon can materialize into an electron and an anti-electron. This anti-electron is also called as positron. So this pair production is a result of transformation of electromagnetic energy into the material particles like electron and positron. It means that this kind of phenomenon cannot take place in all circumstances. There is a prerequisite condition that your photon must have an energy of some required minimum energy that has been put here, and it must be allowed to pass through a very strong Coulomb field. So these conditions are essential to bring in the materialization of electromagnetic energy into an electron and a positron. So it means if this energy, this h nu, if this h nu is less than that of twice m naught c squared, then there is no possibility of pair production. You cannot have the pair production. You cannot have the conversion. You cannot have the conversion of electromagnetic energy into the mass, into the materials like electron and the positron. Moreover, in this phenomenon, there is no violation of charge. There is no violation of energy. Both things are valid. They are not violated. The total charge in this process remains constant, and the total energy in this process remains same. So, according to classical physics, there is no physical meaning of negative energy. There's not anything like where you can say negative energy states, but in quantum mechanics, there is a possibility that an electron can have a discontinuous transition from one energy state to another energy state. So electron can have a discontinuous transition. It can have a discontinuous transition. Means there is no trajectory between these two states, but you have a transition from one energy state to another state. According to Dirac, what Dirac came up with is that there is existence of negative energy states, and these negative energy states are real. These are real negative energy states, but mostly all of these states, the negative energy states, in these states electrons are filled. Electrons are filled in negative energy states. So the electrons generally observed, they always exist in positive energy states. Now the point is condition. That is it possible that you can have a transition from an occupied state? From an occupied state. If you give some energy, some required energy to an electron in an occupied state, and it makes a transition, a discontinuous transition. When it makes a discontinuous transition, it goes to a positive energy state, leaving behind a state which is negative energy state. The state that it leaves behind is simply a vacancy. And this vacancy also becomes visible. It is not only the electron that becomes visible in the positive energy state. The hole that has been developed there also becomes visible. All of its properties are same as that of electron, except the charge. So if you see this this diagram. In this diagram, you can see this line is representing the positive energy states, and the levels below this line are representing occupied negative energy states. And you can see the difference of energy between these two is m naught c square. That means if you meet out the condition that h nu is greater than that of m naught c square, in this case, what happens? The electron, which is invisible in the occupied negative energy states, it makes a transition to a positive energy state. When it makes a transition to a positive energy state, it leaves behind a vacancy. It leaves behind a positively charged vacancy. This positively charged vacancy is called as positron, and all of its properties are same as that of the electron. At the same time, this positively charged vacancy, which is also called as hole, it also becomes visible. It also becomes visible as the electron that has made a transition from this occupied negative energy state to the positive energy state. It has left behind a vacancy. That vacancy also becomes visible. And the necessary condition for that is that your gamma ray photon must have energy greater than that of twice m naught c square, probably in a very, very strong Coulomb field. So this is how Dirac, here I have given a very crude explanation. The actual involvement of mathematics is very, very harsh in this case. So I have given the outcomes of Dirac's electron equation. So in this way, the pair production becomes possible, at least from theoretical point of view, that if you have a highly energetic photon and if it passes via a very strong Coulomb field, and it has an energy greater than that of twice m naught c square, which is nearly 1.02 mega electron volts, then this photon of energy translates into the material particles, electrons and positron. This phenomenon is referred as pair production. I hope you might get some ideas which I have tried to share with you. I hope these things will be helpful for you in your own approach of learning. God bless you all.